Why did sea surface temperatures go up when summer air temperatures did not? This perplexing question arose after last summer's unusual findings. Ocean surface water temperatures off Boston, Portsmouth, and Portland were nearly 2 degrees Fahrenheit warmer than normal, aligning with the long-term trend of increasingly warm conditions, primarily driven by climate change. To understand this, we must dive into the unique geography and ecosystem of the Gulf of Maine. This body of water is nestled between Nova Scotia to the north and Cape Cod to the south. Its connection to the Atlantic Ocean is only through a 60-mile wide deep channel between Browns Bank and Georges Bank. This distinct geographical feature greatly influences the circulation and temperature of its waters. The Gulf of Maine is nourished by several rivers, including the Charles, Mystic, Merrimack, Piscataqua, Saco, Kennebec, Penobscot, and the St. John. These rivers flow into this 36,000 square mile sea, making it less salty than the Atlantic Ocean. During the summer, fresh water from these rivers spreads across the sea's surface. Due to its lower density, it forms a distinct layer on top rather than mixing with the salt water below. This creates a counterclockwise circulation due to the Coriolis effect, bringing nutrient-rich deep waters to the surface on Stellwagen Bank and fostering a rich ecosystem for marine life, especially whales. However, in winter, rivers discharge less water, the circulation halts, and surface waters mix with continental shelf water. In 2023, the Gulf of Maine experienced the hottest sea surface temperatures ever recorded, despite the average summer air temperature being only 70 degrees. This was a stark contrast to 2021, where the average summer air temperature was almost 4 degrees warmer, yet the sea surface temperatures were cooler. So how can we explain this paradox? The answer lies in the rainfall. In 2023, over 20 inches of rain fell, the largest volume since 1955. This rain, falling on hot, impervious surfaces, resulted in warm water flowing into the sea, raising the surface ocean waters by 2 degrees. It's like trying to warm a cup of coffee with a hairdryer. It won't work. But place that cup on a hot plate and you'll see a difference. The same principle applies here. To cool the ocean, we need to slow and retain rainwater on the land with more vegetation, soils, and infiltration to groundwater. More water on the land will enable more photosynthesis to draw more carbon dioxide and further moderate climate change. This paradox of rising sea surface temperatures, despite stable summer air temperatures, is a wake-up call. It's a reminder that every action has a reaction, and every choice we make can have far-reaching impacts on our environment.